Hi all, welcome back to the channel. When we uploaded our last video on the design of the RC beam for lifting, some people came back and said the steel looked quite high. Would you be able to tell us how you calculate the kgs per cube exactly that's in the beam? So what we're going to do is we're going to have a look at the PDF, which is here. The beam is 950 deep, 700 wide. Okay, the min length is 10,188 and the max length is 10,688 because the beam is on a slight curve. Okay, so we'll just take the average then through the middle. In terms of rebar, we have some B32s in the bottom, we have some B16s on the side and some B16s in the top. And the shear links then are B12s. All right, so not too much steel in the unit. Okay, there's a good bit of steel in the unit, but there's not too many bar marks or different shape codes, so this should be quick enough process. What we'll do now is we'll have a look at the standard bar schedule that you would get for a typical beam that looks like this. Okay, firstly, we'll just have a little look at the IFC file first, okay, for the steel. So I've just singled out the beam. I just put a little cut there through it, and we'll pop. No, we don't need to another cut. Okay, so we can see that we have a nice bit of steel at the bottom. We see our B32s are bundled, and we have our sidebars of 16s, and then we have our 12 mil links. Okay, so in terms of the overall steel, like it's a fair, decent lump of beam, and we do have a lot of space in there, like so the kgs per cube, I'd be thinking it's gonna be less than 200 anyway, but there is a nice bit in the bottom. Okay, so let's do the numbers now. Okay, guys, so this will be a typical bar schedule in Excel format for the beam we're looking at. Okay, so I've kind of curtailed it down a little bit. I don't want to show the shape codes or your A, B, and C dimensions or anything like that, just to confuse matters. But basically, all we're looking for is that we have the type of bar, the diameter of the bar, the radius of the bar, the number of members. We've only one beam, okay, the number of bars in each beam, and our total number then, and the length. Okay, so this is all we need in terms of being able to get the kgs of steel that's in the unit. So this bar schedule would come with a drawing. So if you're an estimator and you get in a construction drawing or a precast drawing of a unit, your bar schedule will come with it. It might not always have the kgs, or it might not always have other information, but you will in these if you follow these few steps, you'll be able to get the exact kgs of steel that's in the unit and bring it back to a kgs per cubic meter, which is what we're trying to achieve, and then get the exact weight of the element. So if I unhide some tabs here, which I've just done myself, okay, so there's all the A, B's, and C's. Get rid of them again. Don't want to see them. Over here, unit weight and weight of rebar. So that's all I want to see for now. Okay, we'll go step by step. I have it all done, but I just want to go step by step. And we'll bring in our formula, which I just have over here. Okay. Right. So this formula is how we get the weight of a piece of rebar. So we have a 12 mil rebar, and it's d squared, so 12 squared divided by 162. This works for every diameter of rebar that we have, and it's 0.88. And anyone that knows the rebar will know that is the weight of a 12 mil bar, and 1.58 is the weight. Now these are rounded up for anyone who goes to more than 2 or 3 decimal places. Okay, these are just rounded up. So we have the kgs per meter for the bars. Fair enough. That's in this column here. Then we're multiplying them by the length. Okay, so we're just taking the length, bring it back to meters. So we have 2.27 kgs is what that bar mark 1 is going to be. We have 35 of them, so multiply by 35. So in total, we have 79.33 kgs of rebar in our B12's bar mark 1. We just quantify them all, so you'll see the formulas. Okay, so it's just C3, okay, which are 12 squared divided by 162. And then here we have our 0.89 multiplied by our length divided by 1,000 to bring it back to meters. And here all we're doing is multiplying the total number by the bar, and we get the total. Okay, and all I'm doing is just double clicking on the bottom of the cell, bring them all down, and we get our 1182.91 kg. So we have 1182.91 kgs of steel in that beam. Okay, that's the total amount of steel, right? Okay, so the next thing we want to do is just calculate the volume of rebar. So we know that the area is pi r squared, okay, so just pi r squared by L, and we get the volume. So what we're looking for is we want to see how much volume the steel takes up, take the volume of the steel away from the volume of the unit, and we'll be left with the actual volume of concrete. And then once we get the weight of the concrete and the weight of the steel and add them together, we get the total weight of the unit. Okay, so what we're doing here is we have our pi r squared. Okay, we have the length of that bar, and we have the total cubic meter. I'm multiplying it by the 35 again. Okay, so I'm multiplying it by our 35 number. All right, so bar mark 01, the volume of bar mark 01 is 0.01 meters cubed. All right, so this is just volume meters cubed. Okay, so the total volume is 0.15 when we add them all up together. So there's 0.15 cube of steel in that beam. All right, go on to the volume of the beam itself. So it's 0.7 by 0.95. The average length is 10.48, so the volume is 6.94. All right, and if we were to do it by the standard rule of thumb, reinforced concrete is 2,500. It would mean that we would have a unit weight of 17.35 ton. Okay, hope everyone's still with me here. Moving over to the next, the actual, not the actually, the actual. So the actual weight of the beam, right? So we know steel from the first time is 1182.91 kgs. Okay, we know that the actual volume of concrete is our 6.95 minus our 0.15. So we know that we have 6.79 cubes of concrete in that beam. All right. We know that the weight of concrete, the unit weight of concrete, of unreinforced concrete, is 2,400 kgs per cubic meter. So the kgs of concrete is 16,298. The beam weight then will be the concrete weight plus the steel weight, and our total weight is 17.48 tons. All right, so 17.4 tons is the actual weight of that beam using concrete and steel. And if we bring that back, we have 2,518 kgs per cube, which would be the density of the beam. Okay, density of the reinforced beam. So the rule of thumb would be 2,400 for unreinforced and 2,500 for reinforced, or standard reinforced. So we will be thereabouts, you know. So as I said at the start, if we went for the rule of thumb and we used to get the beam weight, we just got the volume, which would have been 6.95, and then we multiplied by 2.5 to get to tonnage, we would have been thereabouts. Okay, this is just an exact way of doing it. Why is this important? I suppose it's important so that when in the factory, when the concrete guys are ordering their concrete from the batching plant, that they're ordering 6.79 cubes, not 6.95 cubes. So we're all in the world of sustainability, and we don't want concrete to be wasted and thrown away and, you know, whatever. Obviously they don't. The factories will use it somewhere else. But at the end of the day, if you're just pouring this beam and you didn't have anything to do, you'd have wastage. Okay, so we're trying to be very, very efficient with our concrete volumes. And again, with the weight of the beam, like knowing the exact weight of a beam is very important for estimators when they're trying to price haulage and things like that. And again, for cranes on site. Okay, so I hope you found this useful, and we'll leave it at that. And look, if there is any other comments or anything else people would like to see, drop me a comment, and we'll do a quick video on them. Okay, thanks guys. Apologies, I completely forgot to actually give you the kgs per cube after all of that. So you'll see here that the kgs per cube is 170. And what we're doing is we have our kgs 1182.91, and we're just dividing it by the 6.94, which is the volume of the beam. So yeah, I was saying it was going to be under 200 from just a quick look, and yeah, we're at 170. All right. And if we go back up there just for completeness, so the weight of the beam was 70.35 using the 2.5. Okay. And the weight of the actual weight of the beam is 17.48. So a slight increase because of the density of steel in the unit. So just little things just to keep an eye on. Okay. Thanks guys. If you found it useful, like and subscribe. Thank you.